In this presentation we're going to look at set theory, and in particular set difference and symmetric difference. So I'm just going to explain what both of these are. Set difference of sets A and B, denoted A minus B, are the elements of set A that are not in set B. The symmetric difference of sets A and B are the elements that are in either one of those sets but not in both. So what I'm going to do is construct a little Venn diagram here. So we have sets A and B, and A comprises the values of 1 to 6 and B comprises the values from 5 to 9. Now the set difference of A minus B can be described as, or demonstrated as, we'll color it in magenta, this portion of the Venn diagram here. The elements of A that are in A only. Conversely, we could look at the elements of B minus A, the set difference of B minus A. Let's write that down, B minus A. And which area of the Venn diagram corresponds to that? Well, this part here. 7, 8, and 9. Now let's look at the symmetric difference of A and B, and we would write that as follows: A O plus B. And what area of the Venn diagram corresponds to that? It's the area shaded in here pink. So it's 1, 2, 3, 4, 7, 8, and 9. So you could think of it actually as the union of the two set differences together. Now we're going to look at membership tables here. So we're going to fill out the membership table. So first off, A minus B. Well, let's look at column A here first. So if it's not actually in A, that means it can't be in the area of A minus B. So automatically this goes to 0 and this goes to 0. Now this third row here specifies that this element here is in set A but not in set B. So that does correspond to A minus B, the set difference of A minus B. Here this indicates that the element is a member of A, but it's also a member of B. And again, that's not part of the set difference. Let's look at the other one here now, B minus A. Well, first off, anywhere that it's not anywhere where B is 0, B minus A is necessarily going to be 0 as well. 0 and 0. Just to be clear, I'm looking at that there and that there. Now, what we're going to do now is consider where it is a member of B, but it's also a member of A on this bottom row. So that's going to be 0 here as well. This second row here indicates that the element is a member of B but not a member of A. So that would be part of the set difference of B minus A. Now, as I said before, actually, we can actually consider A O plus B, or the symmetric difference of A and B, as the union of the two set differences here. So we could actually get a union of these two columns here. So 0 and 0, the union of that is 0. 0 and 1, the union of that is 1. The union of 1 and 0 is 1. And lastly, the union of 0 and 0 is 0. So just to confirm it there, those are the membership tables for set difference and symmetric difference.